Okay, still on continuation on part B. We are still continuing on part B. Uh, you see what is happening on part B. On part B, we are saying we apply the combination formula. Combination formula, you go to your calculator, then press shift, then press NCR for combination events or combination object of objects basically. So this is a combination formula, then this is a product. There is a multiplication in between. That's why we are applying combination as well as the product formula. So what is important, you need to understand the numerator part, which says pick cats and dogs. So use multiplication rule for picking cats and dogs. Remember yesterday, how did I explain the value of a y? How do we get a y? A 1 for a dog, right? So what is happening? We are getting a 1. The fact that we are going to pick 3 cats out of how many cats? 6 cats. So if we pick 3 cats, remember how many colors do we have for painting these pets? We are having 4 colors. So if we choose 3 cats, then for these colors to for this paint to paint all of these pets, we need to have 3 cats as well as 1 dog. We cannot like take the fourth pet. We cannot say we take cat since we've already taken cat. I think I make sense. So let us come to this one. You just press this one, press 6. You are where do we get the 6? 6 is for number of cats. This is the number of cats that we pick. This one, the same space of dogs. Then this one, it's the dog that is randomly chosen, you see. Then this one represent the number of dogs and cats, the summation. Then this one represent the number of pets being selected, 3 cats and 1 dog. Let us proceed. So here we are now on hypergeometric. So what is important, hypergeometric and binomial distribution, as I've already mentioned, that these distributions are connected. You need to understand the previous distribution in order for you to understand the following or the upcoming distribution. So what is important here, if you look at this one, this is a binomial. A binomial is represented by how many terms? 2 terms, x and a y. If we can name our variables, the first variable as x and a y, and these are independent events in binomial. So you know what we're actually referring to if we refer to independent events. How can we prove independent events? You know, we've already studied about that, how to prove independent events. If a probability of event A times probability of event B is equal to the probability of event A intersection B bayalingana, then we can say those events are independent. But however, we are here, this is a binomial, this is a hypergeometric. These are differences, good people. These are differences between binomial and hypergeometric. So we are going to come to this one. Is this similar? You see what is happening? These are similarities, these are differences. Let us first dwell much on differences. A binomial, triads are independent. You see, triads are independent. Triads are independent. The fact that it may happen that we are having 2 coins and we toss these coins. If like we toss the first coin, we are having 2 coins, right? We are interested to get maybe a number of tails that we are going to get. We know that we can get a head, we can get a head, a T, we can get also a head and a T, and also a T and a head. We know that these are possible outcomes that may happen if we spin these 2 coins. However, the most part that you are being fascinated about, it is the fact that when you are spinning the first coin, the first coin will not determine the outcomes of the second coin, and the second coin will not determine the outcomes that we are going to get on the first coin. That's why we are saying these are independent events. So P is the same for all trials. P is the same for all trials. What are we actually referring to? For instance, if we are saying a probability of, we are spinning a coin, the probability of getting a T is 1/2, probability of getting a head is 1/2. Go to a die, probability of getting any number from 1 to 6, it is 1/6. That's what they are referring to. Go to this one. Trials are dependent on this one, on hypergeometric. They are dependent depending on the K and R. You see, we spoke about K. The K represent the whole set. You see, then we are having the R and the blue, which represent whether we are having a blue color or a red color. You see, so trials depend on the number of colors that are being present inside the container. You see, P is not the same, parameter is not the same. What the writer is actually referring to, we are having 2 red marbles, we are having 3 red marbles. You see, now the probability of getting red marbles is not the same as the probability of getting blue marble. You see, these are dependent. Depending on how many number of colors. It depend. Yabo, i-probability it depend ukuthi ublue une-sample space enganani. For instance, besiku combination angithi sathi probability of selecting 3 cats out of 6 cats is 3/6. However, the probability of selecting a dog out of 7 dogs, it's 1/7. You see, there is a difference. There are no common values. You see.